Hello. I wanted to make a video explaining my new Savefile system because it's a bit strange at first, but I believe it's a lot better than the older system I made. So for those who don't know, I have made a Savefile system for the Dreamcast version of Minesweeper I made a year or two ago. I don't actually remember anymore. Yeah, that save file system worked alright for Minesweeper, but it had a few issues that I wanted to fix. This version fixes a bunch of those issues and also adds in a few extra things I wasn't originally planning to add just yet, but they made it in there, so might as well keep them. So here's the goals of the new save file system. First of all, it has both Dreamcast and PC support. And when I say PC, I mean all computers, all OSs. So it should have support for Windows, Mac, and Linux. I've only tested on Windows with WSL, but the other ones should work fine. There might be some issues if you use a compiler other than GCC, but I don't know because I haven't used a compiler other than GCC. If there is, you can just come to the GitHub page, URL's at the top, and it'll also be in the description. And you head over to the issues and file a new issue here saying it doesn't compile on, say, Mac because it doesn't have this compiler flag or something like that. The new version also has version control. So what I mean by that is, let's say you make your save file, initially it has a few variables, and then you want to add more later on, or you want to remove some variables later on. This new system allows for that. And this was a problem I had with Minesweeper because at one point I realized that one of the variables didn't have enough space in it, so it was possible to get incorrect data saved. So I had to actually make an entire new save file format and do a manual upgrade, and that's why the load times in the very beginning of Minesweeper are quite long, because it's checking for the old save file format and converting it to the new one. So this new version, it will just auto-detect it, and the saving function will automatically upgrade old save files to the new format that you specify. And also, unlike other solutions that do the things I described, this one doesn't take up much space. It just takes your variables and stores them. It doesn't have labels attached to them or anything else. It's not like XML or anything where there's a lot of bloat in it. It's designed for small space usage because, of course, a Dreamcast space is limited on the memory card. I'll get into more details about how limited later on. But first, if you're curious about the old save file system, the one I used in Minesweeper and the one a few people have used in their other projects, then I'll give a brief summary, refresher of that system. If you don't care about the old system and you only want to see the new system, there will be a timestamp on screen, so skip to the time on screen. Okay, let's go over. So first of all, the old one lived in a different repository under my homebrew tests. There will be a link to this repository in the description. And it was under Crayon, Crayon VMU example decrayonized. Because this originally came from my currently private Crayon game framework for Dreamcast. So I made it standalone because a bunch of people wanted to use save file stuff for their own stuff. Here's how the old system worked. You had a struct called Crayon save file details, and then it was recommended to just make a struct of your own, and this contains all of your own game data. So I believe this one file didn't open. Extra structs. You can see it's defined here. And this is actually a copy of Minesweeper's save file. You got the options which control preferred refresh rate, the language, the OS, enabling or disabling sound, and the question marks. You have the record times, record names, your preferred values, and this was the one I was talking about where I had to upgrade it because it was originally an 8-bit variable. but that was too small because it could go above 256, so I had to make it 16-bit. And then we initialize it in one go. We pass in the details. We pass in a pointer to our data. Since all of our data is statically allocated, there's no dynamic memory or any pointers in here, it would all just get passed through. Pass in the size of the struct. And those are the number of Savefile icon frames and the speed that it changes. This is the long... Hang on, let me double check. I can't actually remember. Stuff has changed a bit since then. Okay. So we got long description and short description, which appear on the Dreamcast menu page, and then the app ID, followed by the save file name. So we go back, long description, short description, which is 32 bits, 32 bytes, 16 bytes, 16 bytes, and, well, that's, I forget what the size limit is on that, but that would be the file name. And then from there, you do a bunch of Dreamcast related stuff, set up graphics, load data. Here I'd load in the save file icon and the eye catcher. Eye catcher is also something which appears on the save file manager menu in the Dreamcast. And then I detect if there's any valid save files. In this version, you could use this bitmap to just check if there's any save files which you can possibly save to. The system's changed a little bit in the new version because things are more complex with different versions, but it's still easy to figure out what's what. Then there's an attempt to load a save file, and if it's not there, then there's an attempt to just choose another memory card to save to. I think I actually looked at this and this part of the code wasn't necessary. I don't know what I was thinking when I did this. Then we try to save, and then we manually had to update the valid save files. Save didn't do it for you, which in retrospect I don't know why I did that. The new system's a lot better, trust me. Then you could call a function to get how many blocks your save file was. At that point, it would have potentially saved the save file or thrown an error. So it was alright, but like I said before, limitations are no version support, and also you can't get version support using this method anyway. We're just passing a pointer to the struct, but there's no information saying where every variable is in the struct and how to handle upgrading if we were to say delete a variable or add a new one. Okay, so first things first, once you get to a repository, there's a bunch of readmes in all the folder. I won't read the whole readme at the moment, but there's a few prerequisites you need to have. First of all, there's KallistiOS itself, if you want to build the Dreamcast version. And to be clear, if you only want to use this for PC, or you only want to use it for Dreamcast but not both, then you're fully able to. There's no way you get stuck if you don't have KallistiOS installed trying to install PC, for example. But if you do want to use Dreamcast, you do need to install KallistiOS. I will provide a link in the description on a few guides for Linux and Windows WSL on how to get set up. You'll also need another prerequisite. It's sconstruct, which you install with scones. This is how you install it on Debian devices. It's an alternative to makefiles, and I use them in a few places because it's a lot better with cross-compatibility than Make is. Make is very bad at doing that. At the time of recording, I haven't fully finished converting everything over, so there still is a few makefile stuff left over. But anyway, let's open up the code repository. And I don't even have it open. Good job. Okay, save files. First, we want to go to lib Crayon Savefile, and we'll make a new bash terminal here. So you know, sconstruct is the equivalent of makefile. That's what the file itself is called. And this is just an internal thing to help speed it up. So, if we try to run it, just scones like we did in the command before. At first it's going to throw an error because scones isn't a valid input for building the library. So it wants us to specify a platform, and it wants us to specify debug. Well, we can choose to not specify debug and it will be false by default, which it doesn't say, so I need to add that. So this is a fresh install. Let's just do both Linux and Dreamcast. In case you're wondering why Linux even though we're on Windows, WSL is still Linux, so it's going to build the Linux. That's what it natively sees. If you want to build native Windows, you need to find a native Windows compiler. So we'll build. Starts with Dreamcast stuff, and also the Linux stuff. Nice. And we'll close that. Now we'll go into the demos. So we've got a few demos here, and I'll close the old terminal as well. V1 and V3 and V2 are all part of the same demo. It's actually the same save file upgrading through time. So V1 would be the initial version, V2 adds a new version to it with new variables, and V3 adds some variables and also removes some old ones. PC save file backups are just save file backups of these programs. And you might notice there's a V4 in this folder, even though there's no V4 program. The idea of that is it's to simulate what would happen if you made a release of your game. Let's say it's a beta build, and it's using save file version 2, but later on at full release, you make a few changes to the save file and you now version 5 or something. And then you play the new version and turn it off after a while. And later on you come back, but you decide to put in debug game instead. Maybe because you forgot about the new one, or maybe just by accident. In this case, it would actually detect that you have a v0.5 save file, but because v0.5 didn't exist back then, it will fail to load and the game will recognize it must be some future save file. So that's how you can see what it would look like if you loaded this one in any of these versions. Same thing as loading a v3 and the v2 program. And also block creator is just something I use for debugging. Don't worry about it too much. Okay, so I've got Sublime open. Let's start with v1. And I don't know Sublime apparently. Okay, graphics is nothing important, it's just where I put all the graphic stuff for the Dreamcast stuff. We got main and setup. So, first of all, you notice in extra structs, instead of it actually being a struct like it used to be in the old system, it's now a bunch of pointers and defines for type and length. These values are defined in the library, and it's a way that we can tell one of our functions, which we'll call later on, what type our variable is. And then we have an enum for specifying our variable. In case you don't know how enums work, basically you can set it's basically a define, kind of. So you set the define value, or if you don't set it, it will just be one more than the previous one. So in this case, latest save file plus 1 is 2, which means save file current is actually 2 minus 1, which is 1, which is the same as initial. It's the current one. So I recommend in your programs you all have this. Okay. And we've got a few variables here. We've got some coins, we've got some floats, unsigned 8 bits, and then we have these. So we got a bunch of unsigned 8 bits, an array of them, but we also got multiple links in the arrays. So I'll get into that in a bit. And then let's go to setup. Actually, first let's go to main, because there's something I want to show here. So it's changed a little bit. Here I'm choosing the device ID. So on the Dreamcast you have 8 VMUs at most, because you can put 2 VMUs or memory cards even. Doesn't need to be a VMU actually. You can put 2 memory cards per controller, and there's 4 controller ports, so 8 controllers max, 8 memory cards max. So this just lets you easily choose in-game or in-program which device to save to, or which device to attempt to save to. Then later on down here, we call the setup function, which I'll go into in a bit. Then we try to set the device to the value we chose. If this fails for whatever reason, then both the load and save will also fail. So you don't need to worry about making sure this is valid. Then we also get the size of the save file, this time in bytes, just because the Dreamcast uses blocks, PC uses bytes. I thought it would be easier just to have a function for getting bytes, and then another function for converting bytes to blocks. And in case you don't know, this will print out an unsigned 32-bit number. It's a pretty handy one to prevent a bunch of compiler warnings. Then printing out a bunch of stuff. Checking device status, which I'll get into in a bit. And then finally, freeing the save file and freeing base path, which I'll explain in a bit as well. And also I glossed over it, but save files on the Dreamcast use blocks. One block is equal to 512 bytes, and it's not as simple as timesing a bytes by 512. You've also got to round up. So if you have 256 bytes, then that's one block, even though one block is 512 bytes. And you can only have a maximum of 200 blocks per. You can only have a maximum of 200 blocks per memory card. Although I've heard that you can hack your memory cards to get more, but my save file system assumes 200 blocks. So yeah, if anyone has any of those hacked memory cards, I'd be interested to see what happens on there. Maybe it would work? I'm actually not sure. Anyway, let's look at the setup. So we've got a few functions first. We've got defaults and upgrade save file. I'll get into them in a bit. So first, we have the base path thing. Like I mentioned down here, at the very bottom we have to free it. Up here we set it. This is just to tell you where it's going to save the save files to. Specifically the path where all the save files are located. So on PC, I said just set it to the saves folder. So we go in, and there's our saves folder. This will contain any save files that you try to save. On Dreamcast, it just completely ignores the parameter. You could do this for Dreamcast and not have the if-defs here, but I prefer to just not have the string compiled into the binary and pass in null specifically for Dreamcast. That's because the save file is always going to get saved to the VMU drive, so it doesn't actually matter in the end what you pass in here. Next we have the initialization function, which is a lot smaller looking than the initialization function of the old system. This time we just pass in our details, which is passed in through parameter here, the file name, what the current version is, which as we specified before, that's just this -1, which happens to be initial. And this means you don't need to pass in whatever the latest is yourself. You can just pass in this every time and not have to worry about updating that. Then we have to pass in two function pointers, the defaults and the upgrade function, which again I'll get into a bit. Then we add in the app ID, short description, and long description. And the PC version doesn't actually store the short and long description. That's only useful for Dreamcast. It does, however, contain the app ID, so you need to have this no matter what platform you're running. But these two, for PC only, you don't need them. These are just going to return 0 on PC every time. In fact, these are actually defined functions, macro functions. So they literally are 0 on PC. Next, if we're on Dreamcast, I've included a bunch of the VMU LCD stuff within the library because it's quite closely related to the Savefile stuff, because some memory cards known as VMUs have an LCD screen on them, so they have a lot of shared code, and it just made sense to include it. Although that stuff doesn't actually appear, accessibly in the PC version. So for this program, I have a baked-in ROM disk. That's why I don't need to load it. I load in the LCD screen stuff. I get a bitmap to see which ones are actually present, which screens are present. Then, using Crayon peripheral, which is included in the library, one sec, I set the icons. And so this will set it once for everyone, and the icons will stay there as long as the system is powered on. So you don't need to submit this every frame or anything like that. But if you want to submit a new icon, then you need to resubmit a new bitmap. And now, since we don't need the bitmap anymore, because it's just a static one, we free it. And also on Dreamcast, we need to set a Savefile icon. Again, PC version does not have Savefile icons, and it does not have eye catchers either. And also, you might notice from the old system, the app ID is different. So if you have a save file for an old system and a save file for a new system, this won't try to load it, and that won't try to load this. So don't worry about that if you're playing with both of them at the same time. Okay, I've just got a list of notes. I'm going to check to see if I've set everything at this point I want to. Right. Next, we want to add variables to our save file struct. These are all the variables for version 1. So we have coins, var2, and dunno. They each have a type, and they each have a length. Think of them as an array. So we go back here. This is just an array of one element. This is also an array of one element, and they're all actually arrays of one elements in this case. The first one's type unsigned int 16, then float, then unsigned int 8. For the record, there are only 9 variable types you can use. They are the unsigned and signed 8, 16, and 32-bit integers, the float, the double, which on Dreamcast, at the moment, a double is exactly the same as a float, like literally the same. So if you want to get double precision, well, you can't do that on Dreamcast actually. And the 9th type is char, or character. Then, so I glossed over this before with the weird var2 length and got it over here. This is simulating a struct in a struct. So let's say we got 10 of a struct that all contains the variables lol, hi, and name, which each of them have length 16, 2, and 1. But we have 10 of them because we got an array of arrays. So we go over here, we got our details, we're going over all the structs that we have in our imaginary struct. We first pass in lol, the first one, or the 0th one, its type, length, the initial version, and also I glossed over this before, but var still present just means that the variable is still present in the current system. It hasn't been removed yet. I'll get into removing in one of the future versions. And then we have solidify. So solidify then, well, I'll take a few steps back. First of all, these are pointers, but they're not currently pointing to anything. Even when we've added them, they're still not pointing to anything yet. So I can't just say sf coins 0 equals blah. That's going to cause a memory issue because that pointer is pointing to literally nothing that we define. It's undefined behavior. Solidify is the one that changes the pointers. So we passed in a reference to these pointers before, which are stored internally, and now solidify will point them to actual data. And then from this point on, you can actually do sf coins 0 equals 2, and that will actually work. You can set your save file variables. The reason I had to do stuff like that, where I had to get pointers and take them internally and then manually point them to stuff, is so I have better control behind the scenes of the upgrade function. Solidify also calls one of the user functions that you passed in, Savefile defaults. These are the default values that you pass in. So as you see, the default value for coins is 300, default values for var2 is 3.14, and etc, etc. You can also change this, so let's say in version 2 you wanted to make this free, you could do that, that wouldn't cause any issues. And like I said, I'll get into this in version 3. Okay, let's look at version 2. You can already see there's some extra stuff here. So let's start extra structs. We got our old version 1 variables. They're all exactly the same as they were before. But now we have version 2 variables. We have a single unsigned 8-bit variable, MySpace. We have 2 doubles, which again on Dreamcast they're exactly the same as floats, but still. We have 2 of them. And then we have 128 floats. And you might notice that a float is 4 bytes, 4 times 128 is 512. So that will come in importance in version 3. We've also got a new version down here, the speedrunner update. So even though there's no number assigned to it, this is 2 because initial was 1 and speedrunner is next, so it's the previous one plus 1, so 1 plus 1 is 2. And SF current is also equal to 2. Now let's go back to setup. Starts off the same. Nothing has changed before. To be clear, you should never actually change the init after you've made the first version. If you change this stuff, then it's going to cause issues. However, if you want, you could update the short and long description because they're not essential for version support. They're just stuff that gets displayed on screen. However, the app ID must remain the same because that is important in checking if a save file is valid. And also, if you want, you can choose to change up the icon or the eye catcher. And also the LCD bitmap if you want, but that's not really a save file related thing. And we got all our var1 stuff. It's exactly the same before. And now we have our var2 variables. And we can see they're all added in the speedrunner update. And you can see everything still has var still present. It's fairly straightforward at this point. So, at this point, if we had a version 1 save file loaded in the version 2 program, it would automatically convert it to the version 2 format, and then next time you save, it will save it as a version 2 save file. if possible, which is an important thing I'll get into later. Now let's go to version 3, the final version. So we'll close these, extra structs, and setup. So, first of all, you might notice that a few things have been changed in the older versions. Coins, dunno, high, and garbage are all commented out, specifically just the pointers. The type and a length are still here, because we still need them even though the pointer is gone. We also added in a bunch of new variables, all of length 1. These ones over here is just adding in the remaining types that I hadn't added before. And we have a new version, mistakes made. So this is now version 3. Again, SF current will now be free. We see here that stuff is gone. There's no initialization for coins and the third variable, which was dunno. And we can see there's a new array here. And the upgrade function is actually populated for once. In version 1 and 2 it was empty, but in version 3 there's actually stuff here. We'll go back to that in a bit. So you notice that some of the old version 1 and version 2 variable Savefile add variable function calls have been modified slightly. You can see that where the pointers for some of them previously were, it says null. And also on those ones, the version removed is now mistakes made instead of var still present. So in case it's not obvious, the coins variable, the dunno variable, the high variable, and the garbage variable were all deleted in version 3. Some of them we just completely forgot their values because they just weren't useful for us, but other ones we wanted to keep their values and use them in existing functions. We need to keep the type and length and even the add call specifically, because what we're doing when we're adding variables is we're constructing a history. So here we're saying these were the variables that were added in version 1, here's ones that were added in version 2 and version 3, and we also detail if they were removed, and if so, when. Which is important because let's say we wanted to load a save file from version 1 and upgrade to version 3, then we need to know what the variables were and what the save file looked like in that format. We can tell just by looking at the history that's internally constructed that there was 1, 2, 3 variables plus all of this, which I think equates to 33 different variables technically. Whereas if we actually removed these, instead of just using the remove functionality, then we're disrupting history. And now if we try to load a version 1 save file, it would expect it to only have 21 variables, which is not true. It had 33. So that's why we need to keep a record of everything that ever existed. And then once again, the new version 3 variables, of course, they're all going to be still present because we add them in this version. And then we solidify. You might also be wondering why some of the functions are returning something and we're capturing it. They're all returning something, but in some cases we're not caring about what they're returning. You can see that there's only 2, technically 11 function calls that we're actually caring about the result of. It's the result of the adding of the old coins variable and also of the high variable. We're not caring about dunno or garbage. The importance of this is going to be useful in our upgrade function in order to tell us where the data is located so we can keep those old variables but in a new format. So let's go back up to the upgrade function. I'm going to redo this section because I didn't explain it well the first time. So specifically what we're wanting to do is we got the variables we're deleting, 1, 2, 3, 4. Some of them we want to just completely forget about them because they're useless. Garbage just didn't have any values we wanted, so we're going to forget about it. And Dunno also had values we don't care about. However, in this case, old coins, we do want to keep it because in our case, we want to upgrade it to the new coins variable. If we go back to extra structs, old coin was a 16-bit unsigned variable. New coins is a 32-bit unsigned variable. So if our game requirement was we want to store, you want the user to have a maximum of 999,999 coins, that value is too big for an unsigned 16-bit integer, but it can still hold within an unsigned 32-bit integer. So this is a case of how you would upgrade a function type. And of course, if you realize you had too many, then you could downgrade as well, going from unsigned 32-bit to unsigned 16-bit if you wanted to. And also, to show another case, we've got high being merged into lol, which in case you don't remember, lol is 1 length, high is 2 length. So each 2 high values is going to get formed into the lol variable. So we got up here, and also the array that we're returning all of our addresses into, well, not addresses, indexes into, is global for this object file at least. So we can access it inside the upgrade function. And also that's why I like making my pointers global, so I can access it inside the upgrade function, because otherwise there's no way to access your variables unless they're global, or there's a global way to access them. So, first of all, we got a function to detect if the loaded version was before mistakes is made. This is because the stuff that we're deleting is from versions 1 and 2, and they're first deleted in mistakes made. So we got a for loop to handle the high values. In this case, we're putting them into lol with this logic. So we add if they were even. I can't think of a use case where this would happen, but let's just say that happened. And also the this was old coins. As you see, index 0, and index 1, index 1. So old coins is equal to new coins. And you might be wondering, okay, so why are only some variables present in here? Well, when we upgrade our function, when we upgrade our save data from old version to new version, any common variables that are in both versions, so in this case it would be var2, lol, save name, MySpace, and speedrun, those values are just going to be literally copy pasted from the old one as the new defaults. So it will override whatever default values that you set in the default function. So in this case, we are adding to lol, but it's going to add to whatever the old save file's lol is, not what the default lol is, if that makes any sense. So I think now I'll show off the actual library itself. Gonna have to go up a little. Okay. We'll look in the includes file. We've got Crayon.h and Savefile.h. So Crayon.h is just a bunch of Crayon functions which they come from my closed source Crayon library, but they're also using the Savefile stuff, so that's why they're included here, such as a vector that I made, which is used internally in this function. I don't think any of these functions, again, these are the only functions here that you might directly call. the rest of the functions aren't really necessary. Maybe you might use this peripherals function as well, but these ones you shouldn't ever have to use. Onto the save file. So, first of all, we got the types defined. Like I said, double, float, all the unsigned and signed bits of 32, 16, and 8, and then char, and also types is equal to 9, because again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We also got a few other things here. A few structs that you'll never touch. So, the Savefile data struct, this is where your Savefile data is internally stored in these 9 arrays, but again, you shouldn't touch them directly. You should use the pointers that you passed in. The Savefile version is stored in the Savefile itself, and I've got it set to a 32-bit variable. I think that's actually supposed to be a signed 32-bit variable. No, I'm misremembering. I'm getting confused with another thing. It is an unsigned 32-bit variable, so you can have like 2 billion or something Savefile versions, but if you're doing that, then you're probably doing something else wrong. You shouldn't really be doing that. This is the history struct. It's used in a linked list format, and this is how it figures out how to upgrade something from an old Savefile version to a new one. These structs are created every time you do the add function. We got a bunch of other internal variables. Oh, important thing. I forgot to mention. Well, I did mention that the Dreamcast has 8 save file devices because 8 memory cards. But on PC, I currently have 1, which is just the saves folder. Later on, I might actually modify it so you can have multiple save file devices on PC, but at the moment, you just have the 1. And in case it wasn't clear before, on PC, you only have, this is just a internal header part of a header. I do not know the technical name. But yeah, every save file when you open it up will just say Crayon save file in the hex editor at the top. And then you got the app ID on the next line. The Dreamcast save files have a lot more stuff in their header because it's following the Dreamcast format. And then here is the only struct which you'll ever sometimes look inside of, the details struct. There's a lot of variables here that you shouldn't touch. Here are the ones that it does make sense to touch. Latest version, obviously if you want to tell the user in your game what the current save file version is, then you can display here. And you can also use it to check a save file against the latest version to see if it's newer or older or the same. Save data, again, like I said before, we don't touch this struct. Strings, you don't really have a need to touch it, but I guess you can reference them if you want. These 3 bitmaps, these are the equivalent of valid save files from the old system, or whatever it was called. Because we've got save file versions and upgrading functionality, I had to add in a few more bitmaps to support that. But you don't need to access these directly. There are functions which can get more specific results out of these internal data. You can also check every save file's version. Something I glossed over. Let's just open. You might have noticed that the initial save file version was starting at 1 every time, not 0. There's a reason for that, and that's because internally I interpret 0 as a non-valid save file or a save file or a device that does not contain a save file. So if you try to make a save file in version 0, then you're going to get weird results saying that it's not valid, so make sure just copy the example and start at 1. Save device ID, that's the device you're pointing to, one you're trying to save to and load from. If there's no valid save device, then it will be set to -1, which is basically invalid. And then everything below here you should never touch at all. Okay, so with the functions, there's two sections. There's the functions that you call, all of this stuff, and then there's these internal functions. I won't go into the internal functions because you shouldn't ever have the need to touch them. I will say though that these three functions, these two, you might have a reason to call them. Let's say if you wanted to have a feature on the Dreamcast where, depending on the player's progression, you could change the Savefile icon or the eye catcher, then you might want to just free specifically the icon or the eye catcher and then load a new one. That's the only time where you'd ever have to call these. Otherwise, these are automatically freed when you free the entire save file, which is one of the functions up here. Okay, so let's go through these. Set eye catcher, I mentioned that before. Oh, I'm not at the top, am I? My bad. So there's the initialization function. I covered that before. This is more of an internal function that you shouldn't really have to use. Instead, we've got the macros over here. Like I said earlier, setting the short and long string on PC is literally just returning 0, nothing special. And on Dreamcast, it's calling this function, but with a special parameter. This isn't defined on PC, so that's why I had to do 0 here instead. Setting the icon, that's something I had before. Oh, interesting thing. Even though there's nothing stopping you from making a save file with more than 3 icons, if you do one with 4 frames of icons or more, the Dreamcast BIOS save file manager will just freak out, won't know what to do, so it'll display a yellow background, red cross save file icon, which basically just means it's invalid. It's annoying that it can't handle more than 3 frames of animation for some reason, but someone at Sega programmed that, so yeah, it's unfortunate. There's the eye catcher. Add variable. I went into detail about this before. We got solidify. And yet, to be clear, you should not use your variables before you do solidify, but once you do solidify, you can't add any new variables. That's it. We've solidified our save file. It cannot be changed. The structure of it cannot be changed. You can, of course, change the variables inside of it. There's the load and save functions. I don't like this name. Save file, save data, but I could not think of anything better. The delete function is not actually implemented yet, so don't call this. But once it's done, of course, check if there's a GitHub issue about it, because there currently is, and if it's not there, then you know that it's implemented. But the idea of this is, let's say you want to give the user functionality to delete a save file in-game. This function would do that for you. This is the function which frees the entire save file. It will automatically call the eye catcher and save icon functions down here that I mentioned. So you don't need to worry about calling them manually. Freeing the base path, again, it's over here. Setting device. So, like I said before, you can reference this variable yourself if you want to, inside of the save file detail struct, but you should never change it manually. Instead, you should always use, sorry, I lost my place. You should always use this function, because this will check the free bitmaps that I showed off before, to check if it's even possible to use that device for saving and loading. And to be clear, it will only ever set the save file device if it's possible to load and save the save file on that device, or make a save file on that device if it's capable of storing one. If any of those cases fail, then it just returns -1. There's also a function for checking the exact status of a save file device. So it can range from a bunch of things. There's one where the device just isn't present. So on Dreamcast, let's say you've got a single controller plugged in with nothing plugged into the two sockets, or just a rumble pack and nothing else, then both slots are going to return device, well, status no device, because there's no save device on there. There are other stuff, but the other stuff is the same as nothing. So we say no device. Invalid save file is when you have a save file that fails one of the internal checks, even though it appeared at first to be an invalid one. So an example is, let's say we have a save file with a correct name of, okay, let me just load setup. I loaded the wrong file. Okay, so let's say we have the correct file name, savefile demo3.s, but instead of the app ID being this, it's instead this. It's going to assume that the save file is invalid because, for all it knows, someone else might have just happened to make a save file with the same name but use a different app ID, so it could just be an entirely different save file. So in that case, it would throw the error and return 1 or invalid save file. Next, this is when we have no save file but there's not enough room to save. So let's say our save file takes up a total of 5 blocks, and we have 196 blocks currently used, or 4 remaining blocks of space. We would return this because there just isn't enough space to make a save file, so we won't even let the user try. Down here, it's where we have enough space, so the space is equal or more, the remaining space is equal or more to the space that we would take with a save file. Then this one is when we have an old save file, but we don't have enough room to upgrade it. So we saw with version 2, if we go to extra structs, it added in the garbage function. Well, it added in the garbage variable. Again, 4 bytes times 128 is 512. That is equal to exactly 1 block. So this is 1 block bigger than the previous save file. So if we had 0 blocks of space remaining and we tried to load a v1 save file in v2, it just wouldn't work. It would throw error 4, because although there's a save file, we can't really use it because we can't save. We can load it, but we can't save. So in that case, I just prevent loading and saving entirely, because what's the point in loading a save file if you can't save it later on? That just feels mean and cruel. This version is where we have enough space, so using the previous example, if we have at least 1 block of free space, then we can upgrade because the save file only grows by 1 block. Current is when we have a save file of the current version. It doesn't matter how much remaining space it is, because current is going to have the same amount of space as current. And then future is where we have a save file from a future version, like version 4, for example, that I showed before. And in this case, it will just refuse to touch it. It's going to treat it as something sacred that it just can't touch, because we don't know what it is, and it's probably valuable to the user. So we don't let them save, we don't let them load, and we might not even let the user delete it, but I'm not sure. That'll come in later when I make the deletion functionality. Okay, the device ready function, it checks if the save file can be saved and loaded to. So it internally calls the status function and a bunch of other stuff and figures out, yes, you can use it, or no, you can't. So if we go back to... Oh, and also, I think I forgot to mention that it automatically tries to set a save device inside of the solidify function. So we'll try and find the leftmost valid save device, or lowest ID save device, and let you save to it. But of course, if there's no save devices, then it'll just set it to -1. One other thing I forgot to mention, there's a bunch of Dreamcast image file formats. They're not normal PDFs or JPEGs that you can open up on your computer, but I've made a bunch of conversion programs in the Crayon Utilities GitHub repo, again link in description, to convert PNGs into the required formats. So there's one for making the eye catcher, there's one for making the Savefile icon, and there's one for making the VMU LCD icon. The only prerequisite for these programs is just libpng itself. And you also need to use math as well, because they involve a bit of maths. But the short of it is the eye catcher and the Savefile icons. There's lots of different eye catcher formats actually. There's a PAL 4 bits per pixel format, a PAL 8 bits per pixel format, and just a normal ARGB 4444 bitmap. The PAL 4 bits per pixel is the smallest in size. There are some pieces of information on how big everything is in what is the eye catcher section. Yeah, so type 1 is plain old ARGB, which is almost 16 blocks in size. PAL 8 bits per pixel is just under 9 blocks, and PAL 4 bits per pixel, which is what I use in my demo, uses just 4 blocks. And the Savefile icon is always ARGB, just an old bitmap, although it has a palette. It's been a while since I worked on this last, so I can't remember off the top of my head. But yes, it has a palette of maybe 16 colors. Can't remember off the top of my head. Also, there's no S instruction in this repository, it's all Makefile, so if you're working on Windows, you will need to install some way of just running Make. Although I might change this in the future to also use sinstruct. Okay, so I'm going to show you how to compile and demo the programs. I'm going to show with V2, but compiling works the same with V1 and V3. The reason I'm showing off V2 is it's going to be very easy for me to show you old save files and new save files, because I can easily generate V1 and V3 save files without having to go into a hex editor. So let's just open up here. If you type bash at the top in Windows, it will open up a WSL instance. Also, if you're having weird WSL issues, I highly recommend upgrading WSL to version 2. I had to do that earlier today because another one of my programs wasn't working. So at the moment, we have the sinstruct files. There isn't a second sinstruct file here because this is a new install, but sometimes you might get the DB Lite sinstruct file as well. But the sinstruct will build the PC version. All the intermediates will appear in build, Linux, or whatever OS you're running. So we can see over here, we get our intermediates, the object files, and the executable is found in programs. There we go, and because Linux, again, there's no extension for executables. Also, you might have noticed that I just put scones, I didn't specify the platform. That's because the sinstruct and Makefile system here is a work in progress. Currently, Makefile builds the Dreamcast version, and sinstruct builds the sinstruct version. I just need to convert Makefile over to sinstruct, and then I'll merge them into one. And you'll be able to go scones platform equals whatever, just like before. And you'd also, if you didn't have the library built, you'd be able to build it from here, but at the moment you can't, so you need to build the library separately, like I showed in the beginning of the video. And you can have both the Dreamcast and the PC version built at once because, as you saw, the PC version chooses the right OS. Currently, the make file for Dreamcast just dumps everything in the roots folder. So let's see, make first. This might fail. Okay, yeah. There's a bunch of rules in the make file. There's one here somewhere for, yeah, making a first read .bin. And they call it... I'm blind, but somewhere here scrambled is defined. And then you could just do make scrambled. Okay. Right. So that would be make cdfs, blah. Cool, so this will build a first read.bin. And if you are on Windows, you could use boot dreams to combine the first read.bin with the ip.bin. However, there is a preferred method I have. I've got a separate instruction for building a CDI, and this depends on CDI for DC being a dependency, sorry, not a dependency, being in your environment path variable. So you could just call it as in CDI for DC. Anywhere in the program, anywhere in your environment, and it would work. So I encourage you to set that because you can just do make CDI and it does the whole thing for you. Also note, one of the steps is making ISO. It uses gen ISO image. Hopefully that's installed on every development system, but I'm not sure, so you might have issues with that, and if you do, send me a message and I'll find a workaround for that. Anyway, we built both versions, so let's first try out the PC version. Go Program, Linux, and no extension, good. Now on PC, there's only one save device. We start at index 0, so the only option is 0. If we do -1, it will fail. If we do 1, it will also fail. We have to do 0 exactly, and we notice that both times device ID was set to -1. It's set to -1 whenever it's not valid, but here it was set to 0 because it was valid. The loading failed because there just wasn't an existing save file when we started. Saves were in save, and at the beginning this was empty. But then it had no issue saving, and as we can see, it worked. We got our save file right here. In version 2, we use 822 bytes, and the bitmaps, which again, no need to manually look at them, but for debugging, they were useful for me. And we can see we have one save file from version 2 with status 6. Okay, so let's run the Dreamcast version. I'll use dmul. But first I want to show off something. So this is inside dmul and it's got all my VMUs here. Here's an example of what the program looks like running. I'll show it to you before because there's a screen that will pop up before this appears and it will change stuff. So this is loading a version 2 save file in dmul. As you can see, it's 9 blocks. The version 2 save file is 9 blocks. The versions 1 and 3 are both 8 blocks. In this case, I try to save to save device 5. 5 doesn't actually have anything in it, so fail to load and save and set device ID to -1. And we can see a bunch of different save files. So I can tell you that the final device actually contains a version 3 save file, which of course is future. Everything else is either no save file present, a current save file, or an old save file that we're trying to upgrade. So let's go back here. And actually, before running the program, I'm going to take you to the dmul BIOS menu. I've set a the few shortcuts in my bash environment. So I could just quickly load up DMU and a bunch of other emulators without having to find the executables manually. Okay, so there we go. As we can see, no devices here. I believe I've got this one set to literally no device, and this one's a microphone, which is the same as no device. The first memory card, I'll just get these two on Alt Tab. Actually, yeah, I'll do it like this. Right, so first one, there's no save file in there, and we got status free, which status free means no save file, but there's room. Next one is this memory card. We can see there's no save file, but status is 2, meaning no save file, but it's full. Like I said before, the version 2 save file takes 9 blocks. 9 plus 192 is 201, which is not enough. We've only got 8 free blocks. And in case you're wondering, I made this save file with the bloat program I briefly mentioned before, so that's what it does. Useful for debugging. Next, we have a save file from the current version. We can easily see that because it's 9 blocks. And also, that's where the eye catcher gets rendered. And this is where the save file icons get rendered, just so you know. And also, the mess behind it, the eye catcher is 4 blocks, and each save file icon is 1 block in size, because each save file icon is 512 bytes. So it has no issue saving that one. Then here, we have a... this is actually my second time recording, my bad. This is supposed to be an old save file from version 1, which will be 8 blocks, plus 191, leaving 1 free block, which means it's possible to upgrade. And as we can see, it was possible to upgrade because I did it in the previous recording. Oh, I forgot to reset my memory cards. Oh well. And over here, similar thing, this is a version 1 save file, but we don't have any free space, so the save file would fail to upgrade because there's no remaining space. And then finally over here, again, 8 blocks. I can tell you for sure it's a version 3, I know that. In this case, if you try to load or save it in the version 2 program, it's just going to refuse. It's going to set device ID to -1 and just not even do it. Okay, so I'm going to save to save device 5, which will fail, just to show you what the initial versions and statuses are of everything. So we got my face on all the memory cards, and we get a bunch of stats. Like I said before, this is version 2, so it's 9 blocks. And if we go over to savefile.h to look at the statuses, let's compare. Okay, so save file 1, where there's no save device at all, no SF room. So it's this one. That's correct. Next one, where there just wasn't enough space for a new save file, there was like a save of 192 blocks. No save file room full, sorry. So that's 2. The next one, it had a current save file already on there, so it just worked, no issues. And the save file showed up as 2 that time, where it showed up as 0 as before. Next we had a save file from version 1, and there was enough room to do an upgrade, so it worked. Next one, there was an old save file with not enough space to upgrade, so it failed. And then there's the 2 devices, which just no device, not present. And then the future save file from version 3. Again, the latest version is 2 in this current version of the program, so version 3 is completely unknown. It's labeled as future. Now, also the device ID, even though we tried setting it to 5, it failed and it automatically set it to -1. And both load and save failed. So let's try let's try and upgrade these two. So 0, 1, 2, 3, so 3 and 4. We'll do 3, which should work, and then 4 will fail. Huh, interesting. The VMUs actually stay present on DMule. Okay, it'll take a few seconds to initialize and then load and save. And there we go. We got a new save file in the current version, and we can access it. Cool, and let's try device 4. And also you will see on top right it would have said save device ID is free because it worked. And this one will say -1 because it doesn't work. Yep, there we go. Didn't work. So a few other things I want to mention. First of all, I've only done testing on WSL Ubuntu and now WSL Debian. And I've used emulators like DMule, I've used Riecast, I think I used one of the Redream versions as well. It all works. I don't have my actual Dreamcast set up, so I haven't tested on that. So it should work on actual Dreamcast console. I can't see why it won't. And it should work on other PC platforms. The next thing I want to talk about is how you can use this in your own projects. So the Crayon Savefile system is under the BSD clause-free license. Now, if you're like me, someone who's legally illiterate, where they just see legal text and they have no idea whatsoever what it means, here's what this basically means. It means you can use it free of charge in any commercial or non-commercial products. So you could use it in a game that you might sell online. The only requirement is somewhere in the game, and I'm not talking about like you have to look in it through the hex editor. I mean somewhere in the actual game where users can find it, there will be a mention that it uses Crayon Savefile or Protofall's Crayon Savefile. And also, if in the future someone makes a port for a Crayon Savefile, so right now it only works on PC and Dreamcast, but let's say Mr. Brad Pitt comes along and he makes a port for the Atari Jaguar, then you would mention in your game that it's using a version of Crayon Savefile ported by Brad Pitt, for example. There are a few things that haven't been added and a few flaws. The first flaw is something that can be fixed. There is no endianness support at the moment. So if you don't know what that means, basically how data is stored internally in bytes and byte orders. So endianness is the order of every 4 chunk of bytes. So if you ran this on a PC with in little endian, it would work. If you ran it on a PC in big endian, it would also work. The issue is if I made a save file in a big endian computer and then copy that save file over onto a little endian computer, then it would fail. And vice versa as well. The reason is because I'm not checking endianness at the moment, but later on I plan to check it and save it always in the exact same format. So no matter how you save or load it, it will always be read in the correct way. That's something I'll do in the future, but it isn't implemented yet. I mentioned before, PC only has one save device. Later on I want to expand it, probably up to 8, like Dreamcast has. The delete function is also incomplete, I mentioned that before. I'll be fixing the scones and make issue. So that's getting rid of the make file and just making scones build it all. And lastly, ports. So I mentioned this a few months ago. I do want to add ports for other systems. So, for example, I'm a bit interested in the PS2, so I want to at one point port this over so it works on PlayStation 2. And just like before, if you only want to use it for PC and not other platforms, then you won't need to install PS2 stuff in order to use it for PC. But if you wanted to make your own port for some platform, then all I ask is just fork the project, and then once you're done, you can make a pull request and provide instructions on setting up and verifying it, just so I make sure that it's not like some port that doesn't actually work. And then once it's confirmed working, then it can be added into the main repository, and of course credit will be given. I'll update the README to mention that port X was made by user Y, and specify that credit must be given. And yeah, I think that's about it for the Savefile system. If you have any questions, just ask in the comments section below. If there's enough comments, if that just wasn't that clear, then I might make a follow-up video explaining a bunch of questions. Yeah, thanks for watching.